Welcome back to our Math 171 video series. Here we'll show you how to solve some higher degree polynomial and rational inequalities. We'll begin with this polynomial inequality. 2x squared times x minus 5 to the third power times x plus 4 is greater than or equal to 0. When you have a polynomial inequality, just like you would a quadratic inequality, we will split it into pieces and set each piece equal to 0. Therefore, we will now say 2x squared equals 0, x minus 5 equals 0, and x plus 4 equals 0. To solve the first piece, we will divide both sides by 2, but 0 divided by 2 is still 0, and we'll have x squared equals 0. If we take the square root on both sides, we will get x equals 0 for our first solution. For x minus 5 equals 0, we'll start with the minus 5, but move it over to the other side, giving us x equals 5. We do the same thing with x plus 4 equals 0, move it to the other side and change the sign, and x will equal negative 4. We're going to place those solutions on a number line. We mark the 0, the 5, and the negative 4 on the number line. Then we make a note of the conditions. The condition that we have to satisfy is that that inequality is greater than or equal to 0. Greater than or equal to means we are looking for positive answers, and we'll be using closed circles, not open. Therefore, we'll place a closed circle at 0, negative 4, and 5. We'll write down our function and then use those closed circles to split the number line into regions A, B, C, and D. We'll begin with region A, and we'll pick an x that is to the left of negative 4, and we'll say x equals negative 5. Everywhere we see x, in all positions where x appears, we will place the negative 5. Now we'll check the signs of each piece of this polynomial. We'll begin with the 2 in front. The 2 is a positive number, and so our first piece of the answer will be positive. We then have negative 5 squared, but any negative squared also gives you a positive. It would be positive 25, but we only really care about the sign. Negative 5 minus 5 gives us negative 10, and a negative to the third power will give us a negative still. Then negative 5 plus 4 will give us negative 1, a negative number. We see here that we have a double negative in our answer, and a double negative will return a positive as the final answer. This means that region A is positive. Since we are looking for positive answers, region A will be part of our final solution. Now we move on to region B. We'll pick an x that is in between negative 4 and 0, and I will choose negative 1. We'll make a copy of the polynomial, but now we replace all the x's with negative 1 instead of negative 5. Now we look to our signs again. We'll begin with the 2 in front, that's positive. Negative 1 squared would give us positive 1, that's positive. Negative 1 minus 5 gives negative 6. Negative 6 raised to the third will give us a negative because any negative raised to the third is still negative. Then we'll take negative 1 plus 4, and this will give us a positive answer. We have a single negative. That single negative will return a negative answer, and therefore everything in region B will be negative. However, we are looking for positive answers because of our greater than or equal to symbol, and therefore region B will not be part of our solution. Now we move on to region C, and we will pick an x that is between 0 and 5. We'll go with positive 1 this time. Now we'll replace all of our x's with positive 1. Here we'll start with the 2 in front, that's positive. Positive 1 squared is still positive. 1 minus 5 is negative 4. Negative 4 raised to the third power will still give negative. And then 1 plus 4 is positive. Once again, we have a single negative, and that single negative means our final answer is negative. Therefore, everything in region C will be negative, and that will not be part of the answer because we are looking for positive answers. Now finally, we'll do region D. Let's pick a number greater than 5, and we'll use 6. we'll have 2 times 6 squared times 6 minus 5 to the third power, and then 6 plus 4. The 2 in front is positive. 6 squared is 36, which is positive. 6 minus 5 is 1. Raised to the third is still 1, so that's positive. And 6 plus 4 is also positive. This gives us all positive answers. Therefore, our final answer for part D is positive. Since we are looking for positive answers, region D will be part of our answer. Now we review our number line and we see that region A and region D are part of the answer. However, there's one closed circle in between two regions that were not part of the answer. We can see that region B and region C won't be part of the answer, but this closed circle at 0 will be part of the answer. We'll fill that in green to show that. Therefore, our final answer will start from region A, which is negative infinity to negative 4. The negative 4 must be closed, so we'll put a square bracket, and we'll put a parentheses on negative infinity. Now, the single value at 0 with that closed circle must also be part of the answer. To show that, we'll put a brace, and then a 0, and then we'll close the brace. The braces show that 0 is a single point that is part of the solution set rather than an interval. The intervals will use parentheses and brackets, but we use braces for single numbers. Finally, we'll move on to region D. That's our other interval that's part of the solution set, and that's 5 to infinity. 5 with the square bracket and infinity with the parentheses. And this is how we write our solution to the polynomial inequality.